Welcome back to my series of solving Project Euler problems in Python. Today it's time for problem number 4, which is to find the largest product of multiplying two 3-digit numbers that is also a palindrome. That is, reads the same both from the front and the end. I am not sure this is a very interesting problem, since how numbers are written depends so much on the base. Here they certainly assume base 10, but in other bases you would get different results. Anyway, I'll just do a loop over all combination of factors and pick the largest palindrome. So first, how to detect a palindrome. I will use Python's method to reverse sequences for that. Just need to convert back and forth a bit between numbers and string and sequences. I'm pretty sure you could also do this with the slice operator and the negative step, but I find that syntax a bit hard to read and understand, so I'm staying away from that one. And then just loop over all the possible factors and remembering which is the largest number we have seen. And in inner loop we only have to check larger numbers than factor 1, since we would otherwise check all the multiplication twice. And if this is a palindrome and larger than the previous largest palindrome, then we'll save this as the new largest palindrome. Easy. And some result output and measuring of the time it took, and we're done. Sometimes these Project Euler problems also have a pure mathematical solution, but I can't really think of one here. Mostly because the problem is based on the decimal number system, and as soon as you include how numbers are written, it's not really math anymore. Weird error. I forgot the closing parenthesis at the line before. Error messages are sometimes a bit confusing. And there we have the answer. 906609. But I wonder how we reached that number. Let's also keep track of the factors so that we can see how we got to 906609. Maybe I should use shorter variable names, but I like these long variable names, even if they force me to do some lane breaks when I use this big font size. And there we see, 913 times 993 is apparently 906609. To make the video a little more interesting, let's see if we can make it faster. As you see, it took a third of a second, which in computer time is a very long time. Maybe it is that I multiplied too many times. So let's save the multiplication in the variable so it only has to be calculated once. So that was not it. In other words, time to do what I should have done from the beginning, run the Python profiler. Profiling a computer program tells you where it spends the time. You can run a Python program in the profiler just by adding -m space c profile, that's lowercase c and uppercase p. You will get a list of functions, how many times they were called and how long they took. Here we can see that the problem is all the calls to is palindrome. So to make the program faster, we will either have to call it much less or make it faster. Let's at least make it a little bit faster by not converting from number to string twice. Just going to run the profiler a second time just to make sure that the numbers are reliable. Yes, looks the same as the first time. We have 500,000 calls to each palindrome, each taking almost no time, but together they take almost a third of a second. We can also see that join takes a tenth of a second, and reversed seems to be missing completely, which is always suspicious. But let's go for the string conversion. I'm using a very large font while recording, so it looks like I will need some line breaks here, but I hope you can read it. If not, please let me know. Code fixed. Let's run the profiler again. That was a bit faster, though I think the real optimization would be to call the function less. Doing no work at all is almost always better than performing the task faster, and I can think of a couple of ways to call the function less. Maybe you can too, and if so, please let me know in the comments. See you next time for more Project Euler.